So today we are going with the demo on big data administration, and this is our today content on the big data demo. So what is big data? So what is Hadoop? So what are the three V's of big data? What is meant by V here? Why Hadoop? Why are we using Hadoop for big data? And what are the different companies that are using Hadoop now? And we will go into the Hadoop components as well as the little bit architecture as well. And what is meant by Hadoop cluster? So we heard about Hadoop cluster. So what is meant by Hadoop cluster? And Hadoop distributions, and what are the different Hadoop distributions that are available now? And Hadoop admin roles and responsibilities that in generally organize in the organizations in generally. So what these Hadoop admin guys do? And we have also included what is our course content as well during the
Okay.
training.
Okay, Kiran.
So let's start with big data. So what is big data? Because it becomes a very buzzword nowadays. So the big data. So basically the big data is nothing but it's a definition of the problem that many of the current organizations are facing nowadays. Because if we go with any organization, which are very big organizations, they are getting huge amounts of the data daily. But the present systems are incapable of processing the huge volumes of the data, and as well as they are incapable of storing the data. Because suppose if my data is in the form of the TBs, it is in the size of TBs or GBs, I can process using my traditional RDBMS systems. But if it is in the size of the petabytes or more than the petabytes, our traditional systems, they are incapable of processing the data. So that's why we require an alternate to process these huge amounts of the data, and as well as storing these very huge amounts of the data. So that's where the big data comes here. So big data here, it is nothing but the problem name, and it is not the solution. Here again I am referring big data is the problem name and it is not the solution. So here we can see like big data is a term that describes the large volumes of the data, that is both structured data and unstructured data. And according to the SAS defined by the SAS, so big data can be analyzed for insights that lead to better decision and strategies as well.
Okay.
So what is Hadoop? So Hadoop is an open source framework that is being developed to overcome the problem that we are facing with the big data. So the main problems that we are facing is huge volumes of the data, to store the huge volumes of the data, and as well as to process the huge volumes of the data. So in order to overcome these two problems, Hadoop came into the picture. So Hadoop, we can say it's a solution for the big data. So basically Hadoop is a distributed platform which is designed for distributed storage and as well as the distributed processing. Here the distributed is the keyword in the Hadoop. So if you can see like in generally how the data generates, because in the present side we can see like this. So every day we are creating 2.5 quintillions of the bytes of the data, and that data is also coming from everywhere, so many sections of the data, so many fields. The data is coming from the so many fields, like it comes from the sensors, social websites, pictures, videos, in general IT systems as well, cell phones. So from the so many different various sections of the data is coming and it's getting generated every day. So we need an architecture to store these huge amounts of the data as well as to process this data. So that is where the Hadoop
Okay.
comes into the picture. So basically Hadoop is designed only to process the very huge amounts of the data. It is not designed for to process or store the less amounts of the data. If we have less amounts of the data, then we can go with our traditional RDBMS systems. Hadoop is not the best fit in that scenario. Hadoop is the best fit only if we want to process and if we want to store very huge amounts of the data. Then only we can get the good
Okay.
results from the Hadoop. So, we heard about three V's of the big data. So what are the three V's? Are nothing but the volume, the variety, the velocity. So volume is nothing but what is the volume of the data, like terabytes, petabytes. So these volumes of the data that present systems are incapable of processing them. Suppose if you go with the terabyte, teradata. So teradata is capable of almost processing terabytes of the data. But what about the petabytes of the data? But the traditional systems are lacking with these features. So this is the one of the three V's of the big data, volume. And another V is the variety. So what is variety is nothing but, see, if we go with our RDBMS systems, what they do, in generally they process the structured data. But what happens if we have unstructured data? If I need to process unstructured data, how can I do that? And if I have some semi-structured data, then how can I do that? Our traditional RDBMS systems, they are lacking with that feature. So I need a system which should be capable of processing any kind of the data. That is another V, which is called variety. So what about velocity, which is another V? So velocity is kind of, see, we have different types of processing. One is batch processing and another one is a real-time processing. So batch processing is means, like suppose today I run one query. So I will run the same query again later. So it's in the kind of batch processing. It's like cron tab. We in generally what we do is that we write a script, put it in the cron tab, and we set it to run like for every hour. So every hour it runs. So that is called a batch processing. And we have another processing is called a real-time processing. That means whenever we get the data, it should be processed immediately. In the batch processing, it's not like that. So I get the data, I process it after some time, and I see the result after some time. So at the end, my data should be processed both in the batch processing as well as the real-time processing. Regarding what is the amount of the data, it should not matter. And regarding what is the variety of the data, it should not matter. So here, each V is interconnected to the other one. So my systems, my RDBMS systems are lacking with all these features if I need to process huge amounts of the data. So that is where the Hadoop comes into the picture. The Hadoop is a solution for the big data which is capable of storing huge amounts of the data and storing different varieties of the data like structured, semi-structured, unstructured, and as well as designed for processing huge volumes of the data as well as different varieties of the data as well. Okay. So here if you see, so why we are using the Hadoop? So don't we have any other thing to process or to store this kind of data? Yes, at present we don't have any other solution for the big data. Only Hadoop is the solution that is available in the present generation for for handling this big data. If you can see this slide, see, we have different things like, so it overcomes the traditional limitations of the storage and compute. Because in the traditional systems, what we do in generally, we actually take a very big machines. Like we need to store the data in the very big servers. But Hadoop doesn't require that much of machines. So Hadoop requires cheap commodity hardwares. Commodity hardwares are nothing but our just like desktops. So Hadoop doesn't require very big servers or very big machines. It requires normal commodity hardware to store the data and as well as to process them. And for the cost wise also, Hadoop is a adopted project with Apache, and it's a complete open source project, and it's a open source software, and we can get the software without any cost. So for the cost wise also, it's very cheap when compared to other softwares. And scalability is like, actually we have two kinds of scaling. One is vertical scaling and another one is horizontal scaling. Vertical scaling is like kind of adding hard disks. Suppose if my present system is having 500 GB of the hard disk, that hard disk is not sufficient to store my data. So I have some around 800 GB of the data, but my hard disk is capable of handling only 500 GB of the data. Then what should I do? In generally what I do, I remove the 500 GB of the hard disk and I put 1 TB of the hard disk and I will store this 800 GB of the data. So this is called vertical scaling. We are increasing the hard disk size. And what Hadoop does is, it does a horizontal scaling. Horizontal scaling means we put another node. So suppose I have a machine having 500 GB of the capacity, my data is 800 GB. What I do is that I will add one more machine to the present system and I will form a two node cluster. It is called two node cluster. So what it will do is that it will split the data, that is 400 GB in one machine, 400 GB in another machine. So this is called horizontal scaling. So Hadoop supports horizontal scaling. And also we know that it's a low cost open source software. It is completely free
Okay.
software.
Okay.
So what are the different companies that are currently using the Hadoop? So we can see Yahoo, Amazon, Javens, and there are so many companies like Facebook, LinkedIn, AOL, New York Times, and so many companies that are currently using the Hadoop softwares. And the major contribution is done by the Hadoop. The major contribution is done by the Yahoo guys for the Hadoop, and Yahoo is the major company that is currently using the Hadoop. And as far as my understanding, it has almost 40,000 nodes of Hadoop cluster running in their organization. That is a very, very, very big cluster. So here I will just explain about what are the different Hadoop components. So as I said before, Hadoop is for distributed storage and distributed processing. So for the distributed storage, HDFS does the part. So HDFS, nothing but Hadoop distributed file system. It is used for the storage wise, and MapReduce, it is used for the processing wise. So HDFS is the distributed storage and MapReduce is the distributed processing platform. So HDFS is nothing but it's a Hadoop distributed file system which is created on top of the normal Linux file system. So this is the HDFS architecture. In the HDFS, actually we have some different components like name node, data node, metadata, blocks. So what is name node is that? So in the Hadoop we have two different things like in the HDFS. So name node and data node. So what is this name node? Is the master daemon. It is the master service, and data node, these are the slave services. So what is this? This name node performs, it controls all the data nodes. In the data nodes, we store Hadoop data in the form of the blocks. Here a block is nothing but it's a piece of our data. Suppose let's take this example. I have 1 GB file. I want to store this file in HDFS. So what happens is that if we are putting the data of this 1 GB file into HDFS, based on this block size, Hadoop or HDFS, it divides the 1 GB file into different blocks. So Hadoop has a default block size of 128 MB, and if we divide that 1 GB file by 128 MB, so it creates 8 blocks. So that means our 1 GB file, it splits into the 8 blocks, and all these 8 blocks are stored in HDFS. These are nothing but data nodes. So in the data nodes, our real data will be stored in the form of the HDFS blocks. 1 GB file into the HDFS data blocks. So the client contacts to the name node. From the name node metadata, the client verifies, okay, what are the different data nodes that are available to place the data. So the client directly contacts those different data nodes, and client puts the data into those data nodes. This is how the actual architecture works. And what is Hadoop cluster is, it is like addition of the slave nodes, because it is addition of data nodes to store the data and as well as to process the data.
Okay. Okay, Kiran. Uh,
And we have some
Kiran.
popular distributions for Hadoop available, and these are Apache, Cloudera, Hortonworks, Mapper, Pivotal, IBM, Amazon, and out of them, Cloudera and Hortonworks, these are the most popular ones.
Okay.
And these are the Hadoop admin roles and responsibilities, like capacity planning, designing, cluster setup, troubleshooting, performance tuning, automation, security, and often they require to perform the
Mm-hmm.
development support as well, other Linux activities and other activities also. And it is our course content. Introduction to big data and Hadoop, and what are the different Hadoop components and versions, and what are the Hadoop modes, and how to set up a Hadoop cluster, and what are the different Hadoop ecosystem tools and their installations, and Hadoop cluster setup, different ways to set up, and what is Hadoop high availability and how to set up, Hadoop performance tuning and security, and troubleshooting. And also we provide the some interview tips as well as we provide the support.
Thanks, Kiran. Thank you very much. I'll be looking forward to attend your classes, sessions. Okay. Thank you.